So, we've now learned what containers are, but where do we store and manage them? The answer: container registries. Container images can be stored on your local machine. If you run the docker build command and build a container image, it's now stored on your computer. But this isn't particularly helpful for distributing that image to others or using it in a staging or production environment. You need a place where container images can be easily stored and retrieved. A container registry is used for the storage and distribution of named container images. While many features can be built on top of a registry, its most basic function is storing images and allowing someone, or anyone, to later retrieve them. Registries can be public or private. When an image is pushed to a public registry, anyone can pull that image. This is useful for open source projects or personal development where you don't mind if others use or inspect your images. Most enterprises will opt to use a private registry, which restricts access to the images so that only authorized users can view and use them. Registries can also be hosted or self-hosted. Several hosted registries are available, such as IBM Cloud Container Registry. In this case, the user doesn't need to deploy or maintain the registry in any way. That's done by the provider. The user can use the registry as they wish. However, there are also registry offerings that can be run in private data centers or on a cloud. The functionality is largely the same in either case, but different individuals and enterprises will have different constraints and intentions that guide their choices. So far, we've referred to storing and retrieving images, but there's some formal terminology that's often used for these operations. When storing an image in a registry, we say that you push an image to the registry. Similarly, when retrieving an image from a registry, we say that you pull an image from a registry. Keep that language in mind: pushing images to and pulling images from a registry. Images are often pushed by developers or through automation and a build pipeline that they've set up. Those images can then be pulled to a local machine, although they're often pulled by systems running in the cloud or on premises, such as Kubernetes. We mentioned that registries stored named images, and we know that the docker build and docker tag commands can be used to name images. But there's a specific format that is generally followed for image naming. The image name usually consists of three parts: the host name, the repository, and the tag. The host name identifies the registry to which the image should be pushed. For Docker Hub, the registry is docker.io. For IBM Cloud Container Registry, the registry is us.icr.io if you're pushing to the registry in the US. Next is the repository. A repository is a group of related container images. Usually, these will be different versions of the same application or service, so the name of the application or service makes a good repository name. Finally, we have the tag. The tag provides information about a specific version or variant of an image. The tag is often a version number, or it could indicate some other characteristic of the image, such as the operating system on which it was built. Let's look at an example. This image name is straightforward. The host name, docker.io, shows that we are pulling the image from Docker Hub. The repository name is Ubuntu, so we know we are pulling an Ubuntu image. Finally, the tag is 18.04, so we are pulling that version of Ubuntu. In fact, the Docker CLI infers the docker.io hostname if it is excluded, so we could run this simpler command to pull this image. Since there are many different container registries available, the additional features they provide help distinguish them. Consider IBM Cloud Container Registry, depicted in this image. The top left box shows capabilities provided by IBM Cloud Container Registry. There is an API for interacting with images, as well as IBM-provided public images and private repositories to which users can push their own images. A feature called Vulnerability Advisor scans images for common vulnerabilities and exposures. By ensuring security before a vulnerability can be exploited, companies are safeguarded from financial losses and negative press. The bottom left shows that users can interact with the registry through a command line or graphical user interface. Finally, at the far right is IBM Cloud Kubernetes Service, which provides authentication to IBM Cloud Container Registry out of the box, making it easy to deploy images from the registry as containers on the Kubernetes service. These are just a few examples, but they show that container registries are much more capable and powerful than a mere storage service. The functionality built on top of container registries boosts their appeal and helps developers work more securely and productively. You should now be familiar with the basic purpose of container registries and how users interact with them. You should also understand the conventions for naming images and the additional functionality that registries can provide to distinguish themselves. In the next video, you'll learn about how to take an image and run it as a container.